Hi, my name is Kutluhan Meydanlı. I'm taking the course of Introduction to Data Science, and this is our project. We are group Metapod, and our topic is climate change effect on world. First, if we are talking about climate change, we need to evaluate the temperature change. So that's what I worked on specifically. In this section of our project, we worked on Berkeley's Earth surface data, and here you see the initial info and initial table content. But afterwards, in order to adapt the data set to our project, we worked on it. So as you see, here is monthly average, and it seems a bit inconsistent. We tried to merge them as a year. We got the yearly average, and so we got something like this. After the merging the data as a yearly process, so we got every year's first ever annual temperature for countries. Why I'm saying first ever annual temperature? Because some countries' data has 17s, some countries has a data of 18s. As you see, it's a bit inconsistent. That's why I said first ever annual temperature. You can see the roadmap in here. After that, as we come to today, we got more consistent data. So every country has the data of 2013. So, and this is the average temperature of countries in 2013. Seems like a bit similar to a previous slide, but here you can see this is the difference. Especially in Ukraine, you can see the difference going to the 10 degrees. Maybe there's not more another change for other countries, but in Europe, in specifically Europe, you can see some increase in temperature. So here are our top 5 changes between first and 2013's data. Top 5 frozen countries are like this. As you can see, they are not too much frozen, 1 or 2 degrees at most. But if we take a look at the top 5 heated countries, we can easily realize that some countries hit to 8 degrees. And especially in Kuwait, it seems like it increased about 15 degrees. And this is a pretty much amount of degree. So after that, we used linear regression to predict the future. This is the average temperature of world in 21-23, almost 100 years later from now. And in the future, there are top 5 countries which frozen the most, and top 5 heated countries, as you can see. Seems like Canada and Denmark will be freezed a lot. In the left side of the slide and right side of the slide, Cyprus, Costa Rica, and Chad will be increased a lot. I don't get why Cameroon's average temperature is -1 degree. There could be a problem, but these and other countries are top heated, and these countries should be tracked carefully about future. That's my slide. So I want to show you some code about this, and this is our code. We used linear regression, as I said before, and by country to get the country's code, and finally we used Plotly Express to visualize the data as the world map. So here this is the part where we get the yearly average of the countries from the monthly average. Here we created some new data sets, new data frames, and it became like this. So here are our world maps, and we spot the difference between years. After these, in here we use linear regression, as you can see here, to predict the 21-23. So here we get the data. As I showed you before, these are the top 5 heated and top 5 frozen countries. Thanks for listening to me. I'm giving my words to Aydın Burak Kuyumcu, who is my teammate. Thank you for listening.
Hi, I'm Aydın Burak Kuyumcu, and I'm going to explain the CIS extent data and crop production data. We see our pair plot of the CIS extent. We see that some of them are really similar and some of them are not. But we look at them in the pie chart. Some of them are really similar. 9.1, 9.0, 8.7, 8.7. Some of them are equal, but none of them are really cool because of the global warming and some of the seasons it's different in some of the Earth's areas. And we look at the line chart, you see after the 90s there's a lot of ice extent here, but before the 2020 There's a little bit less because there's a little less in ice on the sea. And we look at the crop production pair plot, and we see that in value, time, and index data. And after looking at the line chart, we see that after the 90s, there's a lot of crop production here because of the humans needs resources, and in our industry is growing. But before the 90s, there's not zero, there's a little less, not equal to zero. And we look at the code, we use that ice exchange data to write the data, and we look at the info about infos data. We describe the data, and we see is there NN or null data in here. We kind of look at there's a maximum, minimum, and mean data. We made our second data because we want to categorize the data, and we categorize data by months, and we made a pie chart about it. And we categorize data by year, and we made a line chart about it and bar chart about it. And we made a pair plot, and we predict the CIS exchange data. Say, is there any data that dataset does not include? And we look at the crop production data, and we look the crop production data's info, and we'll describe the data, and we look there's an NN in data in here, and we look the maximum, minimum, and mean data, and we categorize data by time, and we made a line chart, bar chart, and a pie chart about it. And we made a pair plot about the crop production data, and that's all. Thank you for listening to us.